Okay, so hopefully you got something close. This is kind of obviously a learning process. It's just something to try, so to see if you can actually get it. You won't have to hand these in. These are just for you to work on your own. But there will be a seriation problem that you will get to work on your own and hand in. I'll talk more about that in a minute, right? But hopefully you got something like this for the first answer. Right, so you could kind of see the slow, gradual progression. This one worked out very clearly, right? So there's a very clear answer, right? You can see that the yellow and the red never overlap. Sometimes that is a good key to you as to where things go, right? Because you know there has to be overlap and transition, and if there's no overlap, right, between two different colors, and they're probably kind of at the ends there. Looking at this one, it was a little bit more difficult. It wasn't as smooth, but hopefully you got something a little bit like this, right? So here you can see there were kind of two introductions as type 2 was fading out, right? So it's something to keep in mind. Now, could you actually do this at an archaeological site? This is kind of, I think it's sort of an amazing thing. You could do this at archaeological sites, right? Like we talked about with our hypothetical scenarios, with classrooms and cell phones and things like that. If you went out to I should mention something first. How do you know which end is which, right? How do you know it's not reversed, right? Well, that takes a little bit of work. If you don't know if one type of style is older than another, then this could be the youngest or it could be the oldest. You could flip it over, right? You're getting sort of the general order. Usually with these types of cases, you're able to figure out that one of these styles is older, and then you can figure out the correct orientation. Right, so if you went out to an area and you collected pottery like we talked about before, and you calculated the percentages right here, this is showing what they used to do in the old days, archaeologists used to do in the old days, just get out graph paper, and using the graph paper, they would make these percentage bars for each site, and they just take their paper clips, they have them all up on a big sheet of paper, and they just start moving these strips of paper around until they actually create a battleship curve. Right? Now this kind of technique is known as frequency seriation. Seriation means series. You're putting something in order. You're putting something in order based on the frequency of the different styles. The relative percentages is the frequency. So you're using frequencies to put things in order. That's why it's called relative frequency seriation. This is a dating technique that we would classify as relative dating. We're going to talk about dating techniques in a couple of weeks, but there's really two kinds of dating techniques. There's relative dating, there's absolute dating. With this kind of dating technique, you don't know the actual dates of these. You can't say, oh, Unit 7 is 800 years younger than Unit 10. You don't have any way to know that based on what you have found. All you could say, for example, is Unit 7 is younger than Unit 10. Unit 10 is younger than Unit 6. Relative. Relative to this, it's younger. Relative to that, it's older. That's why it's called relative dating. All right, let's get now into the archaeological record and preservation and the different kinds of preservation environments, right? Okay, when we speak of the archaeological record, we're talking about the remains of human activity, right? So anything that's left from past human activity. It could be, it could consist of buildings, it could consist of artifacts, it could consist of things that were damaged by people, right? We're going to look at all of this, right? Typically, when we think of the archaeological record, we think of three different kinds of things. We think of artifacts, we think of ecofacts, and we think of features. All right, what are artifacts? These are all examples of artifacts. Stone spear point, ceramic, stone pipe carved into a shape of a bird, right? If you had a piece of wood and it fell into the site, let's say a tree got knocked over, the pieces of the branches fell into, and this is in ancient times, and then the site got buried, burying that wood. Would that piece of wood be an artifact? I think most of you realize no, it would not. Artifacts are different. What are artifacts? Artifacts are anything that is either made or modified by human beings. Right? Now, if an ancient person took that piece of wood and sharpened an end to use for digging, then it's an artifact. Right? If, let's say, a human being ate a meal, right, gnawed off some meat off a bone, threw the bone away in the pit, is that bone an artifact? No. If the human took the bone and changed it into a tool or something else, then it would be an artifact. Okay, so what is the bone when it is not modified? It's not an artifact, it's actually an ecofact. And so ecofacts are remains that tell us about the environment and the diet of the people. They are used by people, but they are not modified, right? So seeds from plants that maybe were eaten, wood from trees that were used, let's say, or maybe wood that actually did fall on the site would not be an artifact, it would be an ecofact. Bones from the remains of the meal, all of those would be ecofacts. So they tell us about the environment, what was available. This is something that we're going to talk about in future weeks as well. They tell us what people were eating. Okay, the last thing are features. This is from Scarabray in, I believe it's in Scotland, right? Features are large artifacts that cannot be moved. So we're talking about walls, floors, tombs, pits, hearths, storage areas. Right? These are all made by humans, but they're not portable like pottery, stone tools, jewelry, things like that. Right? So they are usually called features. These are the parts of the site that usually stay at the site for the most part. Okay, well, what's a site? All of that together, ecofacts, artifacts, features, form a site, right? Any area that shows the remains of past human activity is a site. It could be something ephemeral as a campsite, maybe where hunters and gatherers staying there for a season and then leaving, let's say, only a few traces behind. Or it could be something as large as a city. This is the city of Mohenjo-Daro in modern-day Pakistan that dates to about 2500 BC. Right? So those are sites. Okay, well, whenever anyone did anything in the ancient world, or prehistory, let's say they, had a campsite, butchered animals, ate the animals, and then they left. Right? Well, that happened, let's say, 10,000 BC. Things happen along the way, maybe immediately, maybe a few hundred years later, that change the ultimate formation of the site when archaeologists find it. Right? And this is called site formation process. It's the factors that create the archaeological record. Right? So after people, let's say, leave those materials, what happens next? This is affected by taphonomy, preservation. Right? What sort of changes occur? Typically, we can categorize the changes as cultural, right? Human-produced changes, or natural changes, things that the environment will change an archaeological site, right? So there could be a big difference between the site when it was used by people and what archaeologists find, right? So this is a early Neolithic longhouse in Europe. This is very typical of early agricultural people in Europe, let's say around 5000 BC in Europe. They lived in these thatch houses that had thatch roofs, plastered log construction, pottery on the floor, hearths, living areas. All the wood decays. Right, we're talking about something like Central Europe, Germany. We're going to talk about the different kinds of environments and what's good for preservation. But as you can imagine, Germany is not so good for preservation of wood and those kinds of materials. So the wood decayed, the thatch decayed, all that was left, the timbers are all gone. So all that's left is the kind of the holes where the timbers used to be. Artifacts may be right on the floor surface, but that's it, right? So in order to understand what might be missing and in order to understand these changes, archaeologists have to look at taphonomy and site formation process. You're going to be doing probably a little lab, I think. We're going to get it set next week on taphonomy. You're going to make a little fake site on campus, and you're going to go back to the site every week, and you're going to take photographs, and you're going to see what sort of changes happen over time. We're not going to have an in-class lab this week. We're going to have in-class labs next week, but I'm going to send you emails this week as telling you what group you're in, what day of the week you will be meeting. Okay, one of my favorite sites involving taphonomy is this one, Swartkrans Cave. This is in South Africa. Paleoanthropologists in this cave found fossilized bones of ancient hominids, right, our human ancestors, as well as other animals. Right, some of the bones were broken up, and the immediate assumption was that humans were living in the cave, hunting, bringing those animals back, butchering the animals inside of the cave. Well, when they started to examine the bones more closely, what they realized is that the hominid bones all had these puncture marks on the top of the skull. And they fit exactly the kinds of puncture marks or the kinds of teeth you would see with leopards. And what they realized is that ancient humans, in this case, were not the predators. They were the prey too, right? That what was going on was leopards were hunting animals, including ancient hominids. And leopards like to take their prey up into trees and start feeding on the animal in the tree. As they would do that, these pieces of bone would fall into the cave over time, and so over time you had these large deposits filling up, fossilization took place, and you had the preservation of the site. So here the natural transform is creating the site. In this case, the leopard is creating the site, and archaeologists originally misinterpreted the site because they didn't understand what was going on in terms of taphonomy. Okay, so let's look at some of these changes. Let's say hunters and gatherers, they have a campsite. They're hanging out there for a while. What are some of the things that could happen that human beings could do that might actually change the site? Well, here's a couple of things that human beings could do. One is walking around, trampling. Right? If they keep walking around that area that they just used, they might break down some of those artifacts into smaller pieces, and that's going to affect it, and that's going to affect what archaeologists find. They might deliberately bury things. This is called caching. So they might dig a pit, bury some stuff. This is a cache of Roman coins. They might actually dig into an earlier site in order to throw away their trash. In this case, this trash pit is younger than this stuff on either side of it, right? And it is affecting the site. Or they might reuse building materials, right? So this is something we still like to do, like reclaim wood. If wood is scarce, they may take the wood out of, let's say, an abandoned house and reuse it. Well, that is affecting the site because when you find the wood will actually be older than the house that you find it in, right? So recycling, reuse, trampling, these are all cultural transforms, human transforms that change a site. Okay, why don't you pause the video for just 1 minute, and in your notebook, why don't you write down some examples of natural transforms, things that happen in nature that could actually change a site. Just kind of, if you maybe even if you haven't had a geology class, just from what you've seen in nature, what are some things that can actually change an archaeological site? And we will come back after. Okay, so let's look at some end transforms, natural transforms. Hopefully you came up with a few, right? But there are different kinds of processes that could bury a site, preserve a site, change a site. So some of them would be sedimentation, right? So imagine you had people living in a cave site. You could have different kinds of deposits covering up the remains and hopefully help preserving them for archaeologists in the future. You could have sediments that are deposited by wind, so aeolian sediments. Colluvial deposits are ones that are from around the area, let's say like part of the cave collapsing and bearing part of it. Alluvial deposits, so maybe a river depositing silt on top of things, but maybe the river is actually moving things around as well. Those would all be natural transforms. How about some others? Well, you could have what's known as graviturbation. Right? You have, let's say, an ancient site on a hill slope. Let's say, had a little campsite here. Over time, rain comes and starts to wash some of this material down to the bottom, even erodes some of the earlier deposits and places them now on top of the earlier remains, right? So because of the rain and the wash, they actually flipped over the order of the layers. Rodents could be a big problem. Rodents dig into the site, they remove things, they bring young things down to lower levels. So, sometimes people actually find, foreign artifacts that shouldn't be at this level. They find them, and looking at the stratigraphy in the soil, they realize that's the result of an animal burrow. Maybe it's, let's say, softer material here and harder material around it. And if they find something like a coin that doesn't date to that time period, it might be because a rodent kind of burrowed down and that artifact ended up down there. Or you could have floral turbation, right? So that would be faunal turbation. Fauna means animals, floral turbation plants. A tree grows, collapses, there's a depression under the roots that gets filled in with other things. And then you have animal activity, like the leopard that we saw in that cave. You have gnawing of bones. You have scavenging by animals, right? So you might have a campsite. The hunters and gatherers ate this animal. The bones were left perfectly intact. But then animals came in and started eating the bones and moving them around. And by the end of it, the archaeologist gets maybe only a few or a handful of bones. You can tell on many bones that, let's say, gnaw marks are there, that dogs, let's say, gnawed on the bones. You can see teeth marks, but also dogs like to gnaw off the ends of the bones usually, right? You can see that right here. So if you find a bone that looks like the ends have been removed and there's other kinds of scraping with the teeth, then you know that canine activity was part of the taphonomic process. And so you can have all of these things or a combination of cultural and natural transforms going on together to sort of end up with the resulting site. So let's look at this example. Hunters and gatherers, they build a temporary shelter. Then the river overflows, burying that site. Farmers then build a pit house, right? And they have a hearth. Then the hillside over here slumps down, the river changes course, and people build a later pueblo there on top. And then the pueblo is abandoned, and wind-blown dust accumulates inside the pueblo. The river returns. It cuts through the site and later dries up. So archaeologists can see these deposits in the cut, and then beams are removed from the pueblo and used to build a fence, the recycling. So turbation, disturbance from natural occurrences and also from human occurrences. Okay, so can you reduce, well, obviously, if people were living in ancient times, they didn't really think necessarily about preservation. But cultural and natural transformations can be reduced if, let's say, those remains are buried very quickly, are not left to rot, if there's less disturbance and activity, if they're located in areas where there's not a lot of rivers and things like that. Poor preservation typically occurs with things that, and this is kind of a South African hunter and gatherer kind of site, right? You might have worse preservation if, let's say, things are just kind of left out, people leave, and then erosion takes place and ends up scattering things around. And that's some of the things that you'll be looking at in that little project that you're going to do next week. All right, let's talk a little bit about preservation. Some environments are great for preservation. Some natural environments are horrible for preservation. Right? Preservation is based on many different things: the kind of soil, the amount of water, the amount of oxygen, sunlight, earth movement, the kinds of bacteria or fungi, different kinds of animals, right? Humidity, temperature, all of these things are going to affect the preservation of materials and archaeological site. Different kinds of artifacts are going to preserve differently in different kinds of environments. And really you have, if you want to get very general about it, two types of artifacts: organic and inorganic. Organic artifacts are made from once living things. Anything that was once living is an organic artifact. So made out of wood. This is a wooden bed that then was covered in gold. So it's made out of wood. It was found in King Tut's tomb, perfectly preserved. So organic artifacts would be things that were made out of bone, wood, leather, textiles, hair, hooves to make glue, right? Those are all organic artifacts, right? The other type are inorganic. This is a bronze sculpture. Was on a ship. The ship sank in the Mediterranean, and you can see some of the patina and then the crustaceans from the ocean, but those things were removed, revealing the bronze sculpture beneath. So, or inorganic artifacts are made from non-living materials: stone, baked clay, mud for bricks, metals. Those are all good examples of inorganic artifacts, right? Okay, why don't you pause the video for just a minute, make a quick list of what of the sort of best environments for preservation that you think. What are some of the environments where organic and inorganic artifacts are going to preserve well? Right? And then unpause the video and we'll look at some of these environments. Okay, so hot and dry, especially dry conditions, are great for preservation. This is on the coast of South America, which has one of the driest deserts in the world. Virtually no rainfall in the desert itself. The people, native people in that area for millennia have been mummifying their deceased ancestors naturally by using the desert, wrapping up their dead relatives tightly into bundles, placing them in the desert. The desert takes care of the rest. Those bodies are dried out completely. The moisture is completely sucked out through the conditions, and you have a naturally created mummy, right? So dry, hot conditions are extremely good for preservation. One of the oldest mummies in the Americas is from Nevada, from a site called Spirit Cave. So Spirit Cave Man was found in the dry Nevada desert, dates to about 9,000 years ago. The reed mat, so this is 9,000-year-old reed mat, covering the remains of this person. They also found baskets. They found other things. If this was another kind of environment, and think about what kind of environment would this not survive in, right? If this was another kind of environment, these things would be gone, right? But they are preserved for 9,000 years. Another great environment are bogs. Right? Bogs are these wet, waterlogged areas that have a lot of plant material that has not decomposed, that forms kind of a black liquid that has a lot of tannins, these chemicals called tannins. It's an anaerobic environment. So when, let's say, an animal dies or when a person dies, bacteria from the gut start to spread to other parts of the body and decomposition begins. And so if, let's say, a body was just left out there, it would start to decompose. Bacteria and other things would start to eat away at the flesh, at the muscle, at the tissues. Right? Eventually you would have the skeleton, and that might even be eroded away. Right? Well, this kind of thing doesn't happen in bogs. Bacteria cannot live in bogs. So if let's say a body is placed in a bog, the bacteria will die, the putrefaction and the decay will stop, and the tannins in the water will preserve tissue and muscle and skin and things like that. So throughout Europe, there are people and archaeologists, so people on their own, not even looking for things. A lot of people found these bodies in bogs because they were digging out the peat from the bog to use as fertilizer for their fields. Dig out the peat, and then they find a human body in there. Some of these bog bodies are quite old, as you can see. One of the best preserved is Tollenman from Denmark, dating from 400 BC. Well, what did they find in that bog in Denmark? They found a perfectly preserved man, naked, except for a leather cap and a leather rope around the person's neck. Right? Their skin got tan black from the chemicals in the water, right? But you could see their orange stubble, the wrinkles on their face. I mean, this is incredible preservation. The muscles have atrophied, right? But there's no decomposition here. What was going on with this individual? This individual was killed, and their body was placed in the bog. But this was not a murder, right? In the conventional sense, this was not just getting angry at someone, killing them, and leaving them. This person was sacrificed, most likely, and we know from historical sources that the pagan peoples of Europe, right? So this is pre-Christian times. This is even before Roman conquest times. Had druids and priests, believed in gods like the Germanic gods. This is in Denmark, right? They probably had gods like the later Norse gods, and one of the ways to appease the gods was to provide sacrifices. So this person was sacrificed, hung, was then placed in the bog, and they were perfectly preserved for over 2,000 years. Right? So bogs, things are anaerobic, without oxygen. Anaerobic, most of you probably know, means without oxygen. Bacteria and things like that need oxygen in order to live. If there's a lack of oxygen, bacteria will not be able to live, and so the decaying process will be halted. Another way to do this is cold, extreme cold, freezing. One of the most famous examples of a frozen mummy is the individual sometimes called the Iceman or Ötzi. Right? He was found in the Italian Alps. Originally, he was thought to be a murder victim. You can see this is why his arm was bent. He died face forward, face down on his arm. When they first found him, they thought he was a murder victim. Police were called in, but then they found a copper axe. They found a reed, looked like a cloak, leather shoes, and fur shoes, and they realized that this was an archaeological find. The preservation is amazing. They can see tattoos that were on Ötzi's skin. They could see the contents of Ötzi's stomach and see what he ate. They CAT scanned Otzi and saw that there was an arrowhead stuck in his chest, so he didn't just get lost in the Alps and die from freezing. It looks like people were after him and shot him with an arrow. This is maybe what he looked like when he was alive. So pretty amazing preservation. So hot and dry, frozen, bogs. These are some of the great environments. Another good one is cold freshwater, like the Great Lakes. This shipwreck is about 100 years old. That is, it sank about over 100 years ago. This is the famous Christmas tree schooner. It's off the coast of Wisconsin in Lake Michigan. Because Lake Michigan is a freshwater lake, there are no torpedo worms that burrow into wood. There are very few of the kinds of organisms that would eat up wood. It's a cold environment, so you don't get a lot of other things that might destroy the wood. It's essentially a big refrigerator. And so organic materials will preserve very, very well, right? I mean, for a 110-year-old shipwreck, this is amazingly well preserved, right? So cold, freshwater lakes are also very good for preservation. Okay, sometimes, like we saw with Pompeii, destruction can actually be helpful for archaeologists. Right there, the entire city was buried all at once by volcanic ash, and then left. And so things were left in place. Now imagine if Pompeii just kind of was slowly abandoned over time, or was never abandoned, and during the Middle Ages they built on top of it, and then there was a modern Italian town built right on top of it. Imagine the changes that would have taken place and the worst preservation. But because it was destroyed and abandoned, the preservation is great. So destruction is obviously not good for ancient people, but for archaeologists, turns out to be good in terms of preservation. This is another site. This is in North America, in Washington State, the Ozette site. This dates from the 1700s. It was a Maca tribe, Native American whale hunting village. There was a mudslide, and the entire village was buried by mud. There was no oxygen in the mud itself, so there was really no aerobic activity. There was nothing to eat away at the organic remains, and they preserve really well. Especially, you can see this, what looks like a whale fin sculpture made out of wood with this inlaid shells on it. Really, really amazing. Right? You wouldn't get preservation like that if, let's say, the site was just abandoned and things were exposed and slowly buried. That would not happen. Okay, this may seem a little counterintuitive, but another thing that helps preservation is carbonization. Right? So when people burn stuff and they have a fire, let's say, in a hearth, let's say they're cooking things, and some of the seeds get burned. The burnt carbonized seeds actually preserve really, really well, especially when compared to, let's say, non-burnt seeds. So in many different kinds of archaeological sites, wood and seeds and plant remains, the ones that are going to preserve are the ones that were charred, where a lot of the organics were kind of burnt out of it and left, and the sort of carbonized shell remains. Those are the ones that are going to be preserved. This is a site in Cambridgeshire in England that was burned. If it was not burned, you would not get preservation of the timbers that held up the roof of this house at this time. So it's kind of called, a lot of people now use Pompeii as an adjective or sometimes even a verb, but they will say this is the Pompeii of the United Kingdom, or the Pompeii effect, right, where things are destroyed and then buried quickly, helps preserve things intact, right? So, and carbonization will help preserve organic remains. So what kinds of environments are not good for preservation, right? What kinds of environments, let's say in the United States, where would you have the worst kinds of preservation for organic remains? Where are you going to have lots of rot in the United States? Let's say Nevada, in the desert, you're not going to have a lot of rot. Where in the United States would you think you would have a lot of rot? In areas that are wet, but also wet and maybe hot. So hot, humid areas. So I would say Florida, you would not have great preservation of wood and things like that. The Amazon, right? It's interesting because Amazonian peoples would make things out of wood and thatch and leather, and what is going to preserve? The things they're only going to preserve are things like pottery and stone tools, maybe the impressions of the wood and the impressions from the houses. But a lot of the other stuff that they made out of organics is going to rot away, and it's not going to be left, and you won't be able to study it. So this is something archaeologists have to keep in mind as they work on these archaeological sites. Right? Okay, in the next couple of videos, I'm going to go over a little of the material for thinking strings. You're going to be working on thinking strings assignment 1 this week, and I'll go over that a little bit more just in case you have any questions about it. And also we'll post some of the labs that you guys will be working on. So until then, let me know if you have any questions.